So we could say that the chances to choose a pink one would be 4 out of a total of 9. The blue would be 2 out of 9, and the green would be 3 out of 9, which simplifies to a third. So that is what probability is. It's the number of things for that particular color divided by the total. What would be the probability of choosing a pink or a green? So that's going to be 7 out of 9, pink or green, because you don't mind if you put your hand in that bag, you just want to choose a pink or a green. You don't care which one of those it is, so you've got a chance of 7 out of 9. What are the chances that you could get a green or a blue? Well, that's 5 out of the 9. What is the chances that you could get an orange? Well, that's 0 out of 9, because there aren't any. 5 on a dice. Okay, so let's say you want to roll a dice. What are the chances of rolling a 5? Now, many students, they tell me, oh, that's 5 out of 6, Kevin. But that's not correct, guys. So are you telling me that to roll a 5, you have a 5 out of 6 chance, but to roll a 1, you only have a 1 in 6 chance? So you're saying that it's easier to roll a 5 than to roll a 1. Well, on a dice, there's only 1 5 out of a total of 6. So your chances of rolling a 5 is 1 out of 6. Your chances of rolling a 2 is also only 1 out of 6. A 3, a 4, a 6, and a 1. We can't say that the chances of rolling a 5 is 5 out of 6. That is not correct. Okay, so just watch out for that. What is the chances of rolling an even number? Well, that's the numbers 2, 4, and 6. So how many are there? There's 3 of them. So that's 3 out of a total of 6. And then if you simplify that, that's 1 out of 2. What is the chances of rolling a prime number? Now remember, a prime number are numbers such as 2, 3, and 5. The number 1 is not a prime number. So if to roll a prime number, there's 3 of them out of a total of 6. So that's 1 out of 2. Now what are the chances of rolling a prime number or an even number? Well, the prime numbers would be 2, 3, and 5. The even numbers would be 2, 4, and 6. So how many numbers are there? Now remember, the number 2, you don't want to count that twice. That's only one number. So then there's the number 3, there's the number 5, there's also the number 4, and then there's the number 6. So there's 5 numbers there out of a total of 6. So the chances of you rolling a prime number or an even number when you roll a dice is pretty high. You have a 5 out of 6 chance of doing that. In grade 10, that's the hearts, we've got the diamonds, we've got clubs, and then we've got spades. In each of the 4 categories, there are 13 cards, going from the ace all the way to the king. That's 13 cards, 13 hearts, 13 spades, and 13 diamonds. Notice that there are half of the cards will be black, half of them are red. So what is the probability if you had to choose one card from a deck? What are the chances that it will be red? Well, look at how many reds there are. There's 26 reds out of a total of 52. And so if you simplify that, that's a half. What are the chances that you will choose a heart? Well, there's 13 hearts out of a total of 52. And if you simplify that, that's 1 out of 4. What are the chances that you will choose a red spade? Well, in this deck, you can see that there are no red spades. That's 0 out of 52, which is 0. What are the chances that you would choose a king? Well, there are 4 kings. 1, 2, 3, 4. So that's 4 out of 52, which is 1 out of 13, if you simplify that on the calculator. And then what is the chances of choosing a heart king, or a king that is a heart? Well, there's only one of those. So that's 1 out of 52. What are the chances of choosing a 2 or a 3? So it doesn't matter if it's a 2 or a 3. So your chances are going to be all of the 2s and all of the 3s added together. So there's 8 of those. So that's 8 out of 52. And if you type that in on the calculator, it will simplify to 2 out of 13. So that's it for this video. I really hope that you have learned some nice basics on what probability means and how to use it. I'm going to show you what numbers we have available to use. Now, event A is prime numbers. Event B is even numbers. Show the above events graphically. Now, what you could potentially want to do is you could make a circle over here and a circle over here, and we could call this event A, and we could call this event B. Now, for event A, all the prime numbers. Well, prime numbers would be the numbers like 2, 3, 5, 7, and that's all. So we can put those over here, 2, 3, 5, and 7. Then for event B, those are your even numbers, 2, 4, 6, 8, and 10. So 2, 4. Actually, we don't have to put the commas like that. And then we're done. But, guys, what we need to realize is that there are some numbers that are in both. Have a look at the 2, and have a look at the 2. So we can fix that up. What we can do is we can rather draw it like this. We can make the 2 circles intersect, and parts that are in both circles can just go over there, and then event A will just have its 3, 5, and 7, and then event B will just have its 4, 6, 8, and 10. And that's it. This is what we call a Venn diagram. A Venn diagram is just a way to show things using circles. Now, let's talk about a few interesting things that your teacher has most likely mentioned. Words such as mutually exclusive, exhaustive. Yeah, let's talk about those for now. Then something I forgot is that we need to put a big box around the outside, because some numbers haven't been used. 2's been used, 3's been used, 4's been used, 5's been used, 6, 7, 8. The numbers 9 and 1, however, have not been used, so they got to go somewhere. They go there. So, mutually exclusive. What that means is, if your 2 circles ended up looking like that, then that is called mutually exclusive. Pretty much what it means in everyday language is that these 2 circles don't have anything in common. For example, this 2 is in both. That's why they are linked up. But if they're not linked up, then we call it mutually exclusive. Exhaustive. Okay, now when you think of exhaustive, exhaustive means that all of these values went into the circles. Well, did they? No, they didn't, because number 1 and number 9 didn't get used up. Okay, so these 2 events, A and B, are not exhaustive, and they are also not mutually exclusive. So A and B are not mutually exclusive, because if they were, they would look like these 2 guys over here. Those 2 circles, they're not mutually exclusive, and then they're also not exhaustive, because if they were, everything would be on the inside of the circles. A and B are not exhaustive. And then your teacher might have spoken about the word complementary. Now, complementary, if 2 events are mutually exclusive and exhaustive, then we will say that they are complementary. So that's mutually exclusive, meaning that the circles don't touch each other, and exhaustive, meaning that everything fits into the circles. If they have both of them, then we will say complementary. So if we had these 2 events over here, events A and B, would these 2 events be exhaustive? Well, exhaustive means that all the values are in the circles. Well, yes, they are, because we can't see anything on the outside over here, so they are exhaustive, so we'll give them a nice green tick. Are they mutually exclusive? Well, yes, because mutually exclusive means that the 2 circles don't intersect, and so yes, they are. So, because both of those work, we can say that they are complementary. Okay, so events A and B are complementary. So if we look at these 2 things over here, event A is all the odd numbers and event B is all the even numbers, represent the above on a Venn diagram. Okay, so a Venn diagram looks like this. Well, we know that it's got a box, and it's going to have two circles. Why? Because it's got two events. But now I don't know if I should make them like intersect or if I should keep them separate, like that. Well, it's quite easy. The one is odd numbers and the other one is even numbers. So they're not going to intersect. So they're definitely going to be separate. Okay, so event A, event B. Event A is all the odd numbers. Okay, so if you don't mind just sitting here for a few hours while I write out all the odd numbers that we have in our number universe, 1, 3, 5, 7, 9, 11, and a few hours later I'll probably get to 1,000,001. However, something's missing because clearly we could go on with this forever. The sample space. So the sample space tells you what numbers you have available to choose from. So let's say we're going to go from 1, 2, 3, 4, 5, and 6. So these are the only numbers we can choose from. Okay, so odd numbers will just be 1, 3, and 5. 1, 3, and 5. And then your even numbers will be 2, 4, and 6. 2, 4, and 6. Okay, so are these mutually exclusive? That means do the circles cut into each other or not? Well, they do not touch each other, so they are mutually exclusive. They are excluded from each other. Are they exhaustive? Exhaustive means that everything inside here must be in one of the circles. It can't be somewhere on the outside over here. So yes, all of the data has been used, so we can say that they are exhaustive. And so are they complementary? Well, yes, they are. Why? Because they are mutually exclusive and they are exhaustive. So I can see they say TV, then they talk about rugby, then they talk about hockey, and then I just see hockey, rugby, TV the whole time. So there's three categories. That means that they are going to be three circles within a big box because we're drawing a Venn diagram. And 99% of the time, the circles are all going to overlap. So I'm going to draw three circles, not like that, okay? Because if you had to draw the circles like this, it would mean that this event here, let's say this is event A, would never be able to link up with event B or event C. So these two circles won't be able to connect to each other. So what I mean is the following, like that, okay? Now, event A, we could, for example, call that television, and then the other one would be rugby, and then the last one is hockey. Okay, so we'll put hockey down over here. Then what I'm going to do is just highlight each circle, and now we just start filling things in. So the first thing they tell us is that 30 people watch rugby. Guys, that does not mean we go and put a 30 over there. The 30, remember, TV is this whole green circle, so it means that this part, this part, this part, and this part should add up to 30. But we don't know how much must go in each part, so we can't use that value just yet. Next one, 35 play rugby. That does not mean 35 goes there. We don't know exactly where that 35, because this one plus this one plus this one plus this one should give us 35. So we can't do anything with that just yet. 40 play hockey, we can't do anything. 20 play hockey only. Now we're talking. Where would people who only play hockey? Well, that's over here, right? It's not overlapping any of the other circles. These people only play hockey. They don't play TV, and they don't watch TV, and they don't play rugby. Whereas if I put the 20 over here, now that 20 is inside the blue, pink, and green circle, and that means that those people do all three. Okay, so we've used this one. 5 people do all three. Okay, so we can put 5 over there. 5 do none of the activities. So they're going to go on the outside. They don't do hockey. They don't do rugby. They don't watch TV. Then 10 play hockey and watch TV. So 10 people play hockey and watch TV at the same time. So where does this hockey circle and the TV circle overlap? Well, if you had to look at the TV circle and the hockey circle, they would overlap in this part over here. Now they've told us that that part should add up to 10, but because we already have a 5 here, then 10 minus 5 is 5, so we can put a 5 over there. Now we're starting to get somewhere because check this out. The blue circle is hockey and it's almost complete. We know that there are 40 people who play hockey in total. 20 of them are there, 5 of them are there, 5 of them are there, so that's already 30. So we can put a 10 over there. Oh, and I've just realized I forgot one of the steps out. Okay, sorry, I'm going to add one more thing. Thought something was wrong for a second, and then I looked over onto my page that I have, and I've left something out. So I've just added this piece at the bottom that 8 people play rugby and watch TV. So where does rugby and TV intersect? Well, that's this part over here, and they've told us that that should be 8, which means that if this is already a 5, then 8 minus 5 is 3. Now, TV is almost complete. We just need the last piece, and they told us that there are 30 people who watch TV, so that's 5, this is already 5, 10, 13, so that's 17 people to go over there. And then for rugby, they say there are 35 people. Well, that's already 10, 15, 18, so 17 people go over there. And that's it, guys. That is how you complete a Venn diagram. So I really do hope that this video made sense to you and that you now feel more comfortable with Venn diagrams. I'm definitely going to add 1 or 2 more in the next lessons just to make sure that you guys have enough practice. What we can see here is height and then eye color. Now, all that you need to do is create a table. So this, and then let height go this way and then let eye color go down, or you can do it the other way around. It really doesn't matter. So let's say we say height goes across. So the height will be tall and then short, and then let's let the eye color go down. So then we would have blue, brown, and green. And so now we have our table. So for example, the person over here is tall with blue eyes. Okay, so tall plus blue eyes. A person over here is short and has green eyes. A person over here is tall plus green eyes. Over here is tall plus brown. You see how easy this is? Over here, it's a short person plus blue eyes. And over here, it's a short person plus brown eyes. So here's a few questions now. For number 1, it says determine the probability that someone has blue eyes. Okay, so there are 6 main categories over here. 1, 2, 3, 4, 5, 6. People with blue eyes would be over here. This one and this one. So that's 2 people out of 6. So you could say 2 out of 6, which would simplify to 1 out of 3. Next one, determine the probability that someone is short. Well, short is all of these people. 1, 2, 3. So that's 3 out of 6, which is a half. The next one says determine the probability that someone is tall with blue eyes. Well, tall with blue eyes is only this one over here. So that would be 1 out of 6. Here's another question. So here we have main 2 categories here would be winning and losing and rain or sunshine. So you can decide how you want to do your table. You can let the win and lose go this way and the sun and rain go that way, or you can let the sun and rain go across and the win and lose go down. It really doesn't matter. So for example, we could go win and then lose, and then you don't want to put the rain and sun next to it like that. You want to do it at the top, so sun and rain, because then it allows you to easily create your table. So this part here would be win and sun. This part here would be win plus rain. This part here would be lose plus sun, and this would be lose plus rain. So let's do some questions. So the first one says determine the probability that it will rain. Well, rain is going to be this part and this part, so that's 2 parts out of a total of 1, 2, 3, 4 different parts. Okay, so that's 2 out of 4, which would simplify to a half. So that one is a half. Number 2, determine the probability that it will be sunny and the team will win. So sunny and win is over there, so that's 1 part out of a total of 1, 2, 3, 4. So that's 1 out of 4. So I hope you see that the tables are very easy. You just take the 2 categories and you can draw the table however you want. We could have also had sun and rain like this, and then lose and win over here. What you don't want to do is something like this. You don't want to say sun and lose and then win and rain. What you want to try to do is keep the categories together. So sun must go with rain and then win will go with lose. Pull out a blue marble, or you could pull out an orange. Now, of course, you could go draw 7 blue arrows and you could go draw 3 orange ones, so you'd have a total of 10 arrows, but that's complicated. What we'd rather do is the following. We will say that the probability of a blue, well, out of a total of 10, 7 of them were blue, and out of a total of 10, our chances of getting an orange were 3. Now you have to imagine which one. So let's imagine that Kate chose blue. Okay, so she's gone this way. Now you completely forget about this part. We'll get back to that later. So now Kate is about, okay, so she's taken that marble out, she's put it back, and now she's about to do her second attempt. So when she puts her hand into the bag now, what are her possibilities? Well, once again, she could draw a blue, or, of course, she could draw orange. And her probability, well, for the blue, well, there's still 10 marbles left in the bag because she put the other one back, and so there's still going to be 7 blue ones, and the probability for orange would still be 3 out of 10. If, however, and we'll look at this in a future question, Kate did not put the other marble back, then there would only be 9 marbles left, and we would have to change things up a bit. Now, let's imagine instead that Kate went down this path the very first time. Well, then when she does her next draw, these are her 2 possibilities, and once again, the possibilities or the probabilities would be 7 out of 10 and 3 out of 10. Now that everything's complete, we need to look at the different combinations. So if Kate did this, that would be a blue marble and another blue marble. So I'm going to call this the blue-blue branch. Likewise, this will be the blue-orange branch, not branch. This would be the orange-blue, and this would be the orange-orange. So now the next question says, determine the probability that Kate draws 2 orange marbles. Okay, so her first one is 3 out of 10, and the next one is 3 out of 10. So what would go in between that? Would you say or would it be and? Does she draw an orange or another orange, or does she draw an orange and another orange? Well, she draws an orange and another orange, and so we're going to multiply over here. If it was or, then we would use the or formula. Remember, we looked at this in one of our previous videos, that if it says and, you have to multiply. If it's or, you plus. So to memorize this, whenever you work on a tree diagram question, to work out the probability of a specific branch, you multiply. And so if we had to multiply these now, we would get a total of 9 over 100. Number 3, determine the probability that Kate draws 2 blue marbles. So that's the BB branch. So that's 7 over 100 multiplied, not 100, 7 over 10. Sorry, so it's that one multiplied by this one, which is 7 over 10. And that's going to give us 49 out of 100. So her chances of getting 2 blues is 49%, and her chances of getting 2 oranges was 0.09, or so it was 9 over 100, which is about 9%. So her chances of drawing 2 blues are much higher. That makes sense because there's more blues in the bag than orange. Number 3, determine the probability that Kate draws a blue marble. Well, that's quite a lot to ask. A blue marble could be any one of the following branches. This one, because that's BB, so that's blue-blue. She could do this one, which is the blue-orange. Or she could do that one, that's orange-blue. So we would have to go and add all of those together. Okay? So let's do that, and then I'll show you a faster way. So we already know the BB, the blue-blue branch, that's 49 over 100. Let's quickly work out the blue-orange branch, which is this one. Well, that's going to be 7 over 10 times by 3 over 10, which is 21 over 100. Next, we could look at the orange-blue, where that will be 21 over 100. And then for the last one, which is the orange-orange, we already said that that's 9 over 100. Oh no, but we don't want that one anyway, so we only want those first 3. Now, what's very important is that when you take these 3 values now we can add. You don't have to, you mustn't multiply these. These ones you're actually going to add together. And that gives us a 91 out of 100 chance. And that's 91%. Now that makes sense. Imagine you, Kate, and you're busy drawing marbles out of a bag, and you do this twice. The chances that you get a blue are going to be pretty high. I mean, there's 77 marbles of blue and only 3 orange. So you have a 91% chance that you would get at least 1 blue. So Kevin, you mentioned that there was a faster way to do this. Well, yes, we know that if you had, well, the way it works in probability is that if you have to add each of these different branches together, which is all the total outcomes, you should get 100 over 100, which is 1, or 100%. Okay, because if you complete everything, it always equals 100%. For example, if we have Venn diagrams, and let's say those 2 circles completely give us 65%, then on the outside we would have 35%, because we always have to end up with 100% if we're busy with percentages, or 1 if we're busy with probability fractions. So instead of adding this whole branch plus this whole branch plus this whole branch, why don't we just do this? Why don't we just calculate this branch, which is 9 over 100, and then just say, well, that equals 0.09. Now we know that all of the probability should add up to 1, so we could say 1 minus that branch, which is 0.09, and that gives us 0.91, which is the same as 91 over 100, which is what we got over here. So instead of calculating 3 different branches, we only calculated 1, and then just subtract. So let me explain that once more. All 4 of those branches should add up to 1, which is 100 over 100. The bottom branch is 9 out of 100. So if that's 9 out of 100, then it means that these 3 branches over here should give us 91 out of 100. Next question says, determine the probability that Kate draws at least 1 orange. So at least 1 orange, well, that means 1 orange or more. So that would be this branch, and this one, and this one. Because remember, the word at least means that or more. So you can have more. So once again, we could go add each of these together, which would give us 51 out of 100. Or, because we know that these 4 branches should equal 100 over 100, then we could just say 100 over 100 minus this one over here, and that also gives us 51 over 100. So whichever way is best for you. So these are the questions that we're going to do in this video, but I'm going to split the questions up just so we have more space. So here's the first part. At a certain school, there are 64 boys in grade 10. Their sport preferences are indicated below. Now, for those of you that read circles, we need on our Venn diagram. So we're going to need 2. Okay, and then we draw a big box. Right, now there are 64 people in total, okay, so I'm going to put 64 over here. Now we've got rugby and soccer. It says that 22 boys do not play soccer or rugby. So there are 22 boys on the outside here who do not play any of those sports. Now let's listen carefully, let's read carefully, not listen carefully, goodness me. Okay, so 10 boys play both soccer and rugby. Okay, so they play both soccer and rugby, so we'll put them in the middle. Okay, this one's actually quite a nice one. It says that there are 24 boys who play soccer. Now what a lot of you students do is you'll want to go put the 24 here, over here. But that is not correct, okay? Why? Because they said 24 boys play soccer. That means in total. So you've got to look at the whole soccer circle, which is this one here. And that whole circle must be 24. So that means that this part would only be 14. Okay, that's a big area where a lot of students do get confused. We are then told that 28 boys play rugby, so 28 boys play rugby. So that means this whole circle must be rugby. So that means that this part here would just be 18. Okay, and that's it. We have filled in everything on the Venn diagram. Okay, so moving on to the next question. It says, calculate the probability that a grade 10 boy plays soccer and rugby. Okay, soccer and rugby is this part in the middle. So that means, okay, so probability, we're going to say over the total 64, and that's 10. So then you type that on the calculator just so that it can simplify the answer for you. And so that would be 5 out of 32. The next one says soccer or rugby. Okay, guys, when it says soccer or rugby, they're talking about all of this inside here. These are people who play soccer or rugby. These people play rugby. These ones play soccer, both soccer and rugby, and these ones play soccer. So if you're looking for the people who play soccer or rugby, they are over here. Okay, when they say when they say soccer or rugby, it doesn't mean that they can't also play both. Okay, so it includes all of those. So it's the 18, the 10, and the 14, which is 42. So 42 out of the total, which is 64, and then you just type it in on the calculator, and that'll simplify to 21. You can also use percentages if you want, by the way. And then this next one, are the events boys play soccer at the school and a grade 10 boy... Wait, all the events a grade 10 boy plays soccer at the school and a grade 10 boy plays rugby at the school mutually exclusive? Justify your answer. Okay, so let's quickly talk about what mutually exclusive is. Okay, so when things are mutually exclusive, it means that they cannot happen at the same time. So the two circles would look like this. Okay, it's almost like someone doing maths, pure maths, I'm talking about pure maths, and then someone doing maths literacy. Okay, you're not going to find someone who does both. Yes, I've heard of one story in my whole life of someone who did both, but I think that was just, the school was just trying something. But in general, right, like if you look at your own school, there's no one who does pure maths and maths literacy. Those are called mutually exclusive. You don't get this. You don't get pure maths and then interlinking or intersecting with maths literacy. Because if that happened, it would mean that there are some people who do both. So the circles are separate. So if you look at the rugby and soccer, are they mutually exclusive? Well, no, they're not. No. And we can just say there are boys who do rugby and soccer. And that's these 10 people over here. If the two circles were separated, then you could say, yes,